Good morning, all of you, in the session of thermodynamics. In this session, we will discuss about properties of system. Before that, you must know some facts about the properties of system. See, first is that properties are the characteristic of the system. That means system defined by a properties like pressure, temperature, volume, density, mass, etc. And it physically gives the characteristic of the system. Number first. And number second, all properties are state or point. That means it is a state variable. See, if the system will execute from 1 to 2 point via a process, when it will follow some process, it has different state, and all properties which is defined point function. That means it is a locus. Third point is that any variable whose change is fixed by the end state is the property. See, it is like that. Any variable, that means you select x is the any variable whose change delta x, that means x2 minus x1, right? Then if you draw a process from point 1 to point 2, this is your x1 and this is your x. Then these properties will fixed via any path in between 1 and 2. That means if you draw from point 1 to point 2 for any process, the change is it's fixed through all process. That change is known as property. That means if delta x via path A, let's suppose x2 minus x1, delta x via path B, also x2 minus x1, delta x via path C is also x2 minus x1. That means any variable, let's suppose x, whose change is fixed, the change is fixed, right? All the process, let's suppose this is A, this is B, this is C, or during all process the change of x is fixed. That x is known as properties of the system, right? Now if we select a system, this is our system. If we select this is our system, and already told that the system is defined by a property like mass, volume, temperature, pressure and density. Let's suppose the system is defined by these, right? If you divide this system by two parts, equal to parts 1 and 2, you can easily understand that if you divide by two equal parts, the mass distribution just half, volume distribution just half, but the temperature remains same, pressure remains same, density remains same. If you select that in this system there is a water, right? And if we separate this system by equal two parts, the mass will have, volume also have, but the what is the temperature? Let's suppose this is the temperature 20 degrees centigrade. Then if you separate this system in equal two parts, the temperature also 20 degrees centigrade and 20 degrees centigrade. If the pressure is 1 kilopascal, if you separate that, pressure is also 1 kilopascal and 1 kilopascal. If the density of water, let's suppose 1000 kg per meter cube, if you separate that system from two equal parts, density also same. That means what's your observation? Observation is that if the system is defined by a some property in which some properties are divided when the system is divided and some property does not. The property which is divided by the system will divided is known as extensive property, and the property which doesn't affect any is known as intensive property. What is the extensive property here? Mass, volume. What is the intensive property here? Temperature, pressure, density, right? So we can conclude that the extensive property is these properties depend on extent of the system. What is the extent? Extent matlab size of the system. See, if the size will change, the extensive property will change. If the size is divided by two parts, this extensive exactly divided by two parts. Or mass of the system. That means extensive property exclusively depend upon the mass of the system. The example is mass, volume, entropy, enthalpy, electrical charge, and all form of energy. See, with your intuition, if we change, if we divide the system, the mass will distribute it, volume also distributed, entropy is also distributed, enthalpy is also distributed, and electrical charge, because charge has a mass which depends upon the mass of the system. Volume also depends upon the mass of the system. Entropy also depends upon the mass of the system. Enthalpy also depends upon the mass of the system. And electrical charge have also mass, right? So if mass will divided, the charge also will divided, and energy also depends upon the mass of the system. That's why energy will categorize in the extensive property, right? After that, some property is that which doesn't affect by the separation of the system. That means deviation of the system is known as intensive property. Like these properties are not depend upon mass of the system. That means if the system mass will change, this property does not change with respect to changing its mass. Like temperature. See, if a body has a temperature 80 degrees centigrade, if you divide this body, then also the temperature is 80 degrees centigrade. If this is the pressure, if divide this system, also the pressure is divided same density. If in the system there is a water, if we separate this by two system, the water has same density 1000 meter cube, 1000 kg per meter cube and 1000 kg per meter cube. Viscosity is also an intensive property. Why? Viscosity is the properties of fluid. If there is a oil in this system, if an oil has a fixed viscosity at a fixed temperature, that means if you separate the system, the oil has the same viscosity. Like that, thermal conductivity, because thermal conductivity is the property of the material. We doesn't change the material of the property. Just we separate the system by two equal parts. So what is the material from system 1 is the material of the system 2. That's why the thermal conductivity will also same. That means this all property doesn't depend upon mass of the system, but some property depend upon the mass of the system. Mass itself a extensive property. Hence, we can say that the extensive property whose property that depends upon the mass of the system or extent of the system. Extent matlab size of the system. If the size of the system will change, the property will change, like volume. That means a system have 1 meter cube. If you separate by two equal parts, automatically after the separation the system volume is half meter cube and half meter cube. That means it is depend upon the size and also depends upon the mass. That means electrical charge have a mass. If you separate the system, the charge will distribute it. So these properties are extensive property. That means it's depend upon the mass of the system. And other is the intensive property. That means it doesn't depend upon the mass of the system. That means what is the mass? The temperature is same, pressure is same, density is same, viscosity is same, and thermal conductivity is same, because viscosity is the property of the fluid, thermal conductivity is the property of a material, pressure is the property of flow property. That means what is the difference between pressure? What is the pressure? Pressure is nothing, it is a flow property. And density is the fluid property. Very carefully. Why this is a flow property? Why? Because the change in pressure, the fluid flow will change. That means the pressure will flow property and fluid is density is the fluid property. If the fluid will change, the fluid density automatically change. If the flow velocity, the flow of the fluid will change, automatically the pressure will change. So density is the fluid property and pressure is the flow property. Temperature is the thermodynamic property. Viscosity is the fluid property. Thermal conductivity is a material property. These all property doesn't depend upon the mass of the system. Right? Such type of property is known as intensive property. So we can say that thermodynamic, if you define a system, then for a defined a system will execute by a process. And if you draw a process, you must have a property. Thermodynamic property are two types. One is the extensive property, other is the intensive property. Right? Now some facts about that. The ratio of two extensive property are intensive. Why? Because extensive property is the function of mass. Right? Extensive property is a function of mass. If we divide two extensive property, then the mass function will cancel out. Then what is the property come into picture is independent of mass, right? Next, specific properties are always intensive property. Why? Because specific, that means extensive property per unit mass. That means extensive properties per unit mass. That means already extensive property depends upon the mass, right? And you divide by the mass term will cancel out. So what is the result will come into picture is independent of mass. That means intensive property. See, in that means independent of mass. You can remember like that. Intensive property. Okay. Now, the other facts is that the state of the system. See, here we defined a system. There is a big list of the properties. That means if you define a system, The system has temperature this one, pressure is this one, volume is this one, enthalpy is this one, entropy is this one. So we can say that when you define a system, there is a big list of a property. Practically, you can unable to define such a big list of a properties. So in this state of the system, we defined what is the minimum property. What is the motivation of this state of the system? We are trying to that what we are trying to search that what is the minimum property of a system by which the system will define, because there is a system, suppose there is a system, S1, right? Some students say that, sir, system property is pressure this much, volume is this much, and temperature is this much, right? Some students say that, no sir, its entropy is this one, enthalpy is this one, thermal conductivity is this one. There is a big list. How can you fix the property of the system to define the state? That means state of the system. What is the state? State are the condition of the system. State क्या बताता हमारा state ये बताता है तो what is the condition, किस condition पे है. That means a system property is defined by a state. That means this is the state of the system. 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 That means system is defined by a state of the system. Right? See, when a state is fixed, that means the system properties P1 and V1 is fixed. This is a fix. That means the properties are also fixed. Why? Because properties are defined by a state and system is defined by the state. That means if there is a system and the system has a properties, if these two properties is fixed, that means a state is fixed. See, if this is your plane, right? Suppose y and x, and there is a point 1. There is a point 1. The point 1 is the state x1 and y1. That means someone says that what is the property at point 1 of the system? Says that x1 and y1. So x1 and y1 is the state of the system, and it gives the condition of the system. So in which condition the system will exist. That means at a point 1 the pressure is this one and temperature is this one. That means if the pressure and temperature or volume is fixed, the state 1 point is fixed. If the state point 1 will change, the property will change. So state will change. Right. If you define the minimum number of property, if you calculate what is the minimum number of property to require fix the state of the system, this is given by the Gibbs phase rule. What is that? F equal to C minus 5 plus 2, where F is the number of independent property. You may say that minimum number of property. Why? Because we are always bothering about the minimum number. Why? Because maximum we know that, but maximum properties will define the system. It is not a practical. So we always bothering about the minimum number of property, also called degree of freedom. This is nothing. This is equal to C minus 5 plus 2, where C is the number of component, 5 is the number of phase, right? Like this is the relation given by the Gibbs. हम इसे समझते हैं कुछ एग्जांपल्स है. फर्स्ट, you understand, if component is one, right, and phase is one, that means a system has single component and single phase. That means a gas. If we put the value of C equal to 1, of phi equal to 1, F equal to 2, that means there are, that means what is the minimum value? The minimum value is 2. That means two variables required to fix the state. That means if we draw a plane like that, y and x, mind it, this y and x is the property, right? For a gas of a single phase, what is the minimum property? Minimum property is 2. That means what is the x1 and what is the y1? If we draw a common point is 1, that means what is the condition of 1, x1 and y1? That means if a gas of a single phase, there are minimum two properties required to fix the state. That means if you define this point, only two properties like pressure or temperature, only two properties, yeah, pressure and volume, right? Case number second, if single component and double phase system. If you select a system like a single component and double phase system, what is the example? Water and its vapor. Water in its vapor, the component is 1, that means H2O, but phase is 2. What is the phase? Liquid and gas. Other, liquid and solid, these are two phase but single component. What is the degree of freedom? What is the minimum number required to fix the state? Is 1, according to Gibbs law. That is, there are only one variable. Here is only two variable. Here is only one variable required to fix the state. See the beauty. And if the water at 1 atmospheric temperature, if you supply a heat, the water, that means liquid, will convert it into vapor. How much temperature? Temperature is 100 degrees centigrade. If the pressure will change, the temperature will change. That means if you defined one property, other automatically fix. That means what is the minimum number of property to define the state of the system? One, only one. Why? Because other is automatically fixed. That means at 1 atm, the water gets converted into its vapor. How much temperature? It will be 100 degrees centigrade. That means if you defined only one property, other automatically fixed. So we can say that in such a type of a system, that means water and its vapor, water and its ice, that means one component and a two phase, the minimum number of properties is one. That means if you define a pressure, that means if your water have a atmospheric pressure 1 atm, or and you are trying to convert it into its vapor, so you already know that that means 1 atm pressure is given, the temperature automatically fixed. That means if you defined only one property, other property is fixed, right? Number third, if you look that single component and three phase system. That means single component matlab solid, liquid and gas. Single component H2, H2O, H2O. H2 in the form of solid, H2 in the form of liquid, H2O form of gas. That means three phase. Surprisingly, the degree of freedom is 0. That means there is no need about any property to require the state of the system. That means the degree of freedom is 0. That means the three-phase system can coexist in equilibrium a point known as what? Known as triple point. Known as triple point. That means triple point is a point which is equilibrium point. At this point, all properties are fixed. See, what is that? For water, for water, if you define water, that means single component H2O, three phase, that means water, liquid, solid, and gas. There is no need about the property of the system. Why? Because all the property is fixed, like pressure, critical point, pressure is defined, it is 20.09 megapascal, critical temperature 374.14 degrees centigrade, critical volume no? 0.00315. This is a specific volume, meter cube per case. simple compressible system, right? A system is called, now what is the simple compressible system? What is the simple compressible system? Here is the definition. Simple compressible system. What is the simple compressible system? There is some assumption which type of a system categorized in a simple compressible system. In absence of electrical, magnetic, gravitational, and surface tension. That means if you assume any system is a simple compressible system, that means for a simple compressible system, the effect of electrical, magnetic, gravitational, and surface tension will negligible. Also, motion is all absence when you consider a simple compressible system. That means why this will negligible? Why? Because these effects are due to external forces, right? Like gravitational field. Gravitational is the external force. Magnetic Next is the characteristic of the system. What is the characteristic? What is the characteristic? That means khasiyat. What is the khasiyat? Characteristic of the system, and system is defined by a property. You can say that characteristic of a properties. See, properties are state function or point function. If you select any property, that properties are state or point function, and they are independent of path, and properties are exact differential. See, example, if we defined volume, volume is the point function. Why? Because it is defined at a point. That means it is defined by a state. If we differentiate it, that means exact differential V2 minus V1. If you define a property pressure, this is exact differential, that means P2 minus P1. If you define temperature, exact differential T2 minus T1, T2 minus T1, right? Now, see, second line says that they are independent of path. That means if we draw on a thermodynamic plane y and x, or you defined any point 1 v1, if this at this point of a system will execute and it will reaches at point 2 where the volume is v2, right? What is the change? The change is dv, and this is exact. Why exact? See, if you draw any path from 1 to 2, from 1 to 2, from 1 to 2, the change is fixed for any path, path A, path B, path C, path D. This change will fix. That means it is independent of path. The property which is independent of path, that is the characteristic of the property. वही property आपको characteristic बताएगा properties का. और ये properties, this property are exact differential. That means it is a point function. It is a exact differential. That means a point function. It is a point function. It is a point function because point will change. If the point will change, this will change. But if the path will change, the change will remain same. That means it is independent upon the path of the process. Thank you very much.